Today's video is on writing equations for a circle and graphing equations for a circle. The circle is our first conic section that we are going to explore. The definition of a circle is a set of points in the plane equidistant from a fixed point called the center. So if we just kind of sketch what that means, in our coordinate plane, a circle has a center, and a circle then is all of these fixed points that is equidistant from that center. The standard equation for a circle in the coordinate plane was center HK, so we call this center HK, and a radius R, so this distance is radius R, is x minus h quantity squared plus y minus k quantity squared equals the radius squared. Now we're going to be using that formula to write the equation of a circle. So here's example 1. Our center is 8, negative 5, and the radius is 10. So h is 8, k is negative 5, and r is 10. So we plug those into our formulas. We get x minus h squared plus y minus negative 5 squared equals 10 squared. Now let's clean that up a little bit, and we get x minus h squared. That one was fine. Plus, but we're going to write minus a negative. We can always change that to add the opposite. So y plus 5 squared equals, and 10 squared is 100. So we have our final equation of a circle. So I'm going to pause the video, and I would like for you to write the equation for example number 2. Let me clean this up and move over. Here is example number 2. So hopefully you were able to plug those numbers in, substitute those numbers in for h, k, and r to get the formula x plus 3 squared plus y plus 2 squared equals 7 squared, or 49. Let's move on to example 3. There are lots of different ways we can give you the center and a way to find R, and this is another way. A lot of times I'll sketch the picture off to the side so that I can see exactly what the circle might look like. So I draw my coordinate axis, and then just 3, 6 as the center here. Tangent to the x-axis means our circle is going to hit the x-axis at exactly 1 point. So our radius is the distance from this center to that point on the x-axis. So it's a vertical distance, and so we can just count the number of tick marks on our scale, and we know the radius is 6. So now we can write our equation again. So x minus h squared plus y minus k squared equals our radius squared, which is 36. Example 4 is just one more way again that we can give you data and we can find the center and radius. In this case, we need to use our midpoint and distance formulas. So if I sketch over here to the side, again, my circle, I have a diameter where one point of the circle is at 2, 8, and the other point of the circle on the other end of the diameter is 2, negative 2. Now we know that the radius is half of the diameter, so our midpoint is the center of our circle. So we need to remember our midpoint formula. For the x value, we add x1 plus x2 and divide by 2. And for the y value of our midpoint, we add y1 and y2 and divide by 2. So our midpoint is 4 over 2, which is 2, and 6 over 2, which is 3. Our midpoint is also our center. Then, to find the radius, we can find this distance, r, from our midpoint to one of the points on the circle. Either one, remember, radius is the same no matter which direction we go. So, to find the distance from our radius to the circle, the point on the circle, remember the formula is distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. I'm using the point on the circle as my x2, y2, and the center as my x1, y1 to find the distance. So 2 minus 2 is 0, so 0 squared is 0, plus 8 minus 3 is 5. So 0 plus 25 squared, the square root of 25 is 5. And then that is our radius. So using our center and our radius, we can now write our equation of our circle, x minus 2 squared plus y minus 3 squared equals r squared, or 25. So here is the final answer for our equation to our circle. So let's continue on to the second page. Remember, if you have problems writing equations of the circle, or if there's something you do not understand, please bring it up in class tomorrow. So for the following equations, we're going to plot the circles, stating both the center and the radius. Now we need to state the center and the radius in order to graph these on our coordinate grid. So we can write the standard equation over the top of the equation we're given so that I can see what the center HK is. So x minus h squared plus y minus k squared equals the radius squared. So let's move down now. And to identify the center, h is 1, and k, well, we have y plus 2 instead of our standard equation y minus k, but we can always change that to say y minus negative 2, or just think I need the opposite. So the center is 1, negative 2. Our radius squared is 16, so our radius is the square root of 16, or 4. Then we simply plot our center on our graph. I'm going to make it a little larger, a little bit easier to plot. So 1, negative 2, plot our center, and then the radius is the distance from the center to the outside of the circle. So we can do that in any direction. The easiest way is to go vertically and horizontally. So we go up 4, 1, 2, 3, 4, to the right 4, down 4, and to the left 4. Then we can sketch our circle using those 4 points to sketch our circle. So that's all there is to graphing an equation of a circle. So I'm going to pause the video and you are going to sketch the circle given by the equation in example 6. So in example 6, the same thing applies. We can write x minus h squared. Since there is no h value, it has to be 0. So the x value for our center is 0. And then y minus k. K matches up to be 2. And our radius is the square root of 25, which is 5. We graph our center first on our grid at 0, 2. And then each of the directions we have a radius of 5. So here is our center and radius and our sketch of our circle. Hopefully you were able to get that graph drawn. If not, please be sure and ask your teacher during class tomorrow.